Hello, let's solve another example of rational equation. As you have observed, I haven't used the typical variable x. I sometimes use another variables like could be any letter. In this case, I'm going to use letter E, but we have to work exactly the same way as if we were working with a variable x. Let's go. So, first step, we need to have the same denominator in the whole equation. To find the common denominator that we need, what we are going to do is factorize both denominators. The same way we did with numbers, that we factorize the numbers to obtain the lowest common multiple. So here it's the same case, but with polynomials. The ways you have to factorize a polynomial, the ways are three. First would be to extract common factor, which is not possible here. Second would be to use a special product, which is the case. And the other way is using Rufini's rule. So as I said before, this is a special product. You have to realize that this is a square and this is another square. So this comes from an addition times a subtraction, right? Here, this is a polynomial. You could use Ruffini, but since this is a second degree polynomial, we can find the root with the formula of the second degree equation. So let's go. It would be negative b plus or minus a square root of b squared, which is 16, minus 4 times this, which is negative 16, all over 2a, which is 2. And this equals negative 4 plus or minus a square root of 0, which is 0, over 2. Negative 4 over 2, negative 2. We obtain just one result, but it is a double result because I obtain the same thing if I add 0 or if I subtract 0. So this is a double root. It's a value that makes my polynomial be 0. So because of the factor theorem, I can say that this equals e plus 2 times e plus 2 again, or square, which is the same thing, equals 0. Here I have to write the same numerators, e minus 4. And now it's time to find the common denominator. So I need a numerator that is divisible by this and by this, and as easy as possible. That is the lowest common multiple, and in this case we have to take e plus 2 with the highest exponent, that is 2, and we have to take this as well. Okay, and here the same thing, e plus 2 squared, e minus 2. Here our number is 0, so I have to write 0 again, because 0 over something would be always 0. And now let's work on this. If I divide this common denominator by this, the result is e plus 2. So I have to multiply e plus 5 times e plus 2 minus, and then e minus 4, that is what I have. And if I divide this by this, I obtain e minus 2. I'll put it here with more detail. I'm dividing this denominator, which is e plus 2 squared, times e minus 2 over e plus 2 squared. Everything is multiplying, so I can simplify numerator by e plus 2 squared and this. That's why this is the result. And I have to multiply this numerator by this. Alright? So let's go. I can get rid of both denominators because they are the same. And let's develop this expression. I have to use this distributive property and multiply everything. E squared plus 2e plus 5e plus 10 minus, I'll write a bracket, I'll develop it, and then this minus affects everything and I'll change the signs later. So e squared minus 2e minus 4e plus 8, and this equals 0. So e squared plus 2a minus e squared plus 2e plus 4e minus 8 equals 0. Now, this is a second degree equation, but it is not, because look, e squared minus e squared is 0. So it looks like a second degree equation, but it is a first degree equation. So let's place all the terms with the variable here and all the numbers here. So we have 2a plus 7a, 2 plus 5, 7, 7 plus 2, 9, 9 plus 4e, 13e, equals 10 minus 8, 2. That goes to the other side as a negative 2. So e would be negative 2 over 13. And now, a little but very important detail. We have to make sure that this number doesn't make any of the denominators of the original equation be 0, which in this case it doesn't, because all the numbers that will make the denominators be 0 would be 2 or negative 2 or 2, a negative 2 here. So this is the result. I hope you understood. Bye!